Welcome to Module 2. All right. If you think back to the end of Module 1, all right, we looked at the case where we had a graph that had a quadratic function on it. So this is our graph. All right. We showed one that looked like this, all right, which had no x-intercepts, which means we couldn't use graphing to help us find the roots, right? Which means they're complex. Okay? Now, eventually, in Module 3, we're going to get to finding ones with complex solutions. But before we get there, I want to review or maybe introduce for the first time the quadratic formula. Okay? So the quadratic formula is a way that will work to solve every single quadratic function that we come across. Okay? So graphing works for most of them, but if we can't find the solution using graphing, we can use the quadratic formula. Okay? Now, if you've seen this before, right, this should look familiar, and maybe you're ready to work through the practice problems on your own. But if you haven't, right, or you need a refresher, let's go through two examples. Now, these are going to be two examples that have real solutions, right, so that we can check them with graphing. Again, if we have ones that have real solutions, you may use graphing to find the answer, but we're going to need this later on. Okay. So looking at example 1, it says find the zeros of f of x equals 5x squared plus 8x minus 16. And here is our quadratic formula up here. All right, now, if this is your first time seeing it, it looks long and it's got a lot going on, right? But if you follow the procedure and step by step, it can help us solve all these quadratic functions. Okay? So the first thing we have to do is identify what our a, our b, and our c is, because those are what we're going to substitute into the formula. Okay? And for this example, right, because everything is on the same side of the equal sign and in standard form, meaning we have x squared first, then the x, then the constant, a, b, and c are easy. Right? This x squared coefficient is our a, the 8x is our b, and the negative 16 is our c. Again, we just use the coefficients from those terms, 5, 8, and negative 16. Now, we're going to substitute this into the formula, and I'm just going to rewrite the formula with our a, b, and c substituted. So x is equal to negative, and then b was 8, so I'm going to put 8 in, plus or minus, that's how we say that sign, and we'll talk about it in just a second, the square root of our b value, which is 8 squared, minus 4, times a, which is 5, times c, which is negative 16, all divided by 2 times 5. Now I just need to start evaluating. All right? So if we look at this next step, we've got x equals negative 8. We don't need the parentheses. Plus or minus the square root. And this is where I start simplifying. Right? I look what's underneath the square root and get that down to one number. Okay? So I put that in my calculator. When I put that in my calculator, I get 384. Again, I wouldn't try to do that in your head. Just use the calculator that you have with you. All right. And then in the denominator, 2 times 5, I know is 10. Now, at this point, this symbol right here, this plus or minus sign, if you think back to our graphs, right, when we did graphing in Module 1, some of those, most of them had two solutions. Right? There were two different places where we crossed the x-axis. So we're going to get two different answers from the quadratic formula. So at this point, I'm going to split it, all right? At one point, all right, or for one solution, we use the plus sign. So we have negative 8 plus the square root of 384 divided by 10. And the other version, or the other solution, is x equals negative 8 minus the square root of 384 divided by 10. Okay? So the formula shortens itself a little bit by using plus or minus, but now we see those two different solutions coming up. And at this point, right, we will talk in the next module how to simplify this a little bit, but because we have real solutions, we can just put this right in the calculator. All right? So I would, right here, put this whole fraction in our calculator. All right? And when I did that, I got x equals 1.16. Right. Make sure that the 10 is underneath the whole thing. So right away, I would start with the fraction in your calculator and then enter the numerator and the denominator. And when I did the negative version, I got x equals negative 2.76. Okay. So those are our two solutions. Now, if I check it with a graph, so I go to Desmos, I have it graphed 5x squared plus 8x minus 16. And you'll see the two x-intercepts are negative 2.76 and 1.16. All right, let's do another one. Example number 2, a little bit different here. All right, it says use the quadratic formula to solve, and then it says 3x squared equals 5x plus 2. Okay? So one thing we have to do, and this is a place where a lot of students make mistakes, or just forget to do this, we need this to be equal to 0 before we can use our formula, right? Meaning I've got to move all the terms to the same side. Okay? So it doesn't matter which side you collect them on. All right? I get in the habit of moving them all to the side where the x squared is. So I'm going to do minus 5x and minus 2. All right. So I get 3x squared minus 5x minus 2 equals 0. Okay? So I'm going to put that as a note somewhere on your packet. Say get equal to 0 first. All right? Because the formula does not work unless we have it equal to 0. Now we can identify our A, our B, and our C. A is 3 in this case, B is negative 5, and C is negative 2. We have those three coefficients. And we make our substitutions. So x equals negative, and now I need to substitute in B, so negative 5 plus or minus the square root of negative 5 squared minus 4 times 3 times negative 2, all divided by 2 times 3. And you'll notice every time I substitute an A, B, or C, I put parentheses around it. And that will be important in an example like this, right, in two different places. So one is right here, right? If we have a negative 5, a negative times a negative is a positive. So when I rewrite this in simplified form, that becomes a positive 5 plus or minus the square root. And again, I'm going to get everything under that square root down to one number. But please, 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 especially when B is negative, make sure you have parentheses there. All right? If you don't have parentheses, your calculator will give you the wrong answer. Okay? And so when I plug that all in or substitute in my calculator, we get 49 underneath the square root divided by 2 times 3, which is 6. All right, I'm going to split it into my two solutions. We have x equals 5 plus. Now the square root of 49, that's a perfect square, so that's just 7 divided by 6. And we have x equals 5 minus 7 divided by 6. And I can do those without a calculator. 5 plus 7 is 12, divided by 6 would be 2. And 5 minus 7 is negative 2, divided by 6 would simplify to negative 1/3. So there are my solutions using the quadratic formula. Okay, go ahead and get some practice on your sheet, and then in Desmos, we will need this in Module 3 when we have complex solutions.